Okay, the second thing we're going to be doing today is finding the area of hexagons. And to do this, since we skipped a couple chapters, what we're going to do is we're going to take the hexagon, we're going to split it into triangles. And there's going to be 6 triangles. And we could figure out using the polygon sum theorem. That was the thing we learned in chapter 6. The 180 parentheses n minus 2, we can figure out that each angle in this regular hexagon is going to be 120 degrees. And then if we split that into 2, that means that each angle is going to be 60 degrees. So now we know that each triangle is going to be an equilateral triangle, which is going to help us find the area of this entire hexagon. So let's say I tell you that one side length of a triangle is 10. We would know that this other side would have to be 10 as well. To find the area of one triangle, we know that we're going to have to use base times height divided by 2. And we know that the base and the height are perpendicular to each other. So these two 10s are not the base and the height. We have to create a line and find out what the height is. And when we do that, we create a right triangle. And we know that when we have right triangles and we're missing a side length, we're going to use Pythagorean's theorem. Now when we found the height, we changed this 10 to a 5. So for this triangle, this right triangle, one side is 5. We don't know what the height is, and the hypotenuse is 10. So before we can figure out the area, we first have to figure out what the height is. And we're going to use Pythagorean's theorem, a squared plus b squared equals c squared. And we know one side is 5, we don't know what the height is, and we know that the hypotenuse is 10 squared. So when you do that, you're going to get that h squared equals 75, so that the height is radical 75. And for now, let's just go ahead and leave it as radical 75. So we now know that the height is going to be radical 75. And we can plug that into our formula to find the area of one triangle. And when we find the area of the triangle, we're going to be working with, let's go ahead and work with this whole triangle, not just the yellow one. So to find the area of this whole triangle, we know that the height is radical 75. We know that the base is 10. We're going to use the whole thing, 10. And we have to divide it by 2. So 10 divided by 2 is 5, so you have 5 radical 75, and then when you punch that into your calculator, you're going to get some decimal, and that's fine. For now, let's not focus on simplifying radicals. We'll do that second semester. So we have one area of one triangle is 5 radical 75, and the last thing is how many triangles do we have in this hexagon? We have 6. So we multiply by 6, so we're going to have 30 radical 75, and on your test, it's probably not going to be in a radical. So go ahead and punch that into your calculator and find the decimal, and that's going to be 259, about 259.8 is the area of that one. So those are the 3 steps you do to find the area of a hexagon.